So, hello everyone. Am I audible to you all? Can anyone confirm? Hello. Hello. Anyone please confirm? Is the voice audible? Okay, okay. Thank you so much, Nakul. So, let's get started. Let me share the screen first. I think I will give access to everyone who is coming here. Uh, okay, we will do that later. So, let's get started. So, good afternoon, everyone. Welcome to your first week session for the numerical problem solving session regarding the structure analysis course, wherein we will try to solve some problems that you all have covered during the topics taught by Professor Amit Shaw during this NPTEL course. So I am your PMRF scholar assigned for this course. I am a research scholar in Department of Civil Engineering in Structural Engineering Division from IIT Madras. My name is Pranam Mahajan. I am currently pursuing my PhD here. So let's start. So first of all, how we can differentiate between two kind of courses that we are learning. One is structure analysis, and another is design of courses, design of structures. Let me admit, some people are coming in between. Yeah. So how can we differentiate between these two courses? Maybe some of you have already taken the design of structure course, or you can call it as structural design course. But were you able to differentiate between these two courses that you are studying? That what is structure analysis and what is design of structures? So let me give you a brief differentiation between them. In structure analysis, we deal with. I will write some points. We deal with calculation of loads applied over the structure, and we analyze them. Whereas in design of structures, we finalize the dimensions that can be shape and size of the structure member or the member which you have taken into consideration. It could be beam, column, truss, any member on the basis of load acting over them. So what I mean is that, let me add another slide. I will show. I will tell you something. That suppose we have a beam which is which we make it as a simply supported beam, not a cantilever beam, having hinge support at one end and and roller support at another end, containing multiple loadings. That it has a concentrated load P and UDL of Q per meter. So these two reactions, we need to find out that what kind of reaction or movements that are developed in the beam due to the load that are acting over them. So here each and every reactions have different constraints. So let me give you brief overview that what kind of constraint. So this is hinge support, this is roller support. So how we do that? In hinge support, this is hinge support, we have two reactions. One is horizontal reaction and one is vertical reaction. So the constraints that are there in this kind of support are two. Whereas in roller support, only vertical direction is restraining, other two direction, that is we have in 2D, we have vertical reaction, vertical reaction, horizontal reaction, and one moment which can be restrained in all of them. Yeah, one more participant is there. Okay. Whereas if we have fixed kind of a support, here we have three reactions: horizontal reaction, vertical reaction, and the moment that is acting. So in roller support, we have one constraint. In this fixed support, we have three constraints. So what I can say about that, here using these constraints, we can also define what are the degree of freedom in these three kinds of supports. There are many other supports. There can also be one internal hinge. There could also be some guided roller kind of a thing. These are also another kinds of supports which you will learn based upon the types of members you are analyzing in the coming days or coming weeks, and you will see how you will take the reaction in that particular kind of supports. So what will be the degree of freedom? So here we define the degree of freedom in journal way as the total number of free free displacements or rotations available in a member in a member. So example, in fixed support we have three constraints. So in that, all the three kinds of these reaction moment, this reaction horizontal reaction, vertical reaction, and moment. All we have the three. So here the degree of freedom is zero. Whereas in hinge support we have two constraints. So here the degree of freedom is one. Whereas in roller support we have one constraint, that is the vertical constraint direction. So here the degree of freedom will be 2. So this is how we define the degree of freedom. Now talking about this, another thing that I am saying is like how we design a structure. Suppose again we are considering the same beam which is subjected to point load and uniformly distributed load over the section. So here how you will design. So first you will calculate the total load that is acting over the member. It could be dead load, live load, floor load. This is not the part of your current course. I'm just giving you overview that how you differentiate between structure analysis and the structure design. Then you will calculate total load that is there, and then you will factorize this load. After that you will calculate maximum bending moment over this member. It could be beam or anything, frame something, or then you will find then you will try to find what will be you will define the shape, and finally you will develop the what will be the area of steel inside the member. This area of steel depends upon the uh, based upon your reinforcement availability. That is, either you have 8 mm bar, 12 mm bar, 16 mm, and many more. So from this you will calculate number of bars that are required. Number of bars that are required, and thus you will make the detailed diagram of that member. Let me draw it again. You will make the reinforcement, you will make the stirrups here also, and provide secondary reinforcements and primary reinforcements in the structure. And finally, you will check them for shear, bending, and minimum reinforcement. This is how you will design a structure. But in this course, we are generally looking forward that how much will be the load that are acting over the structure, and then what kind of reactions that are developed. This is the main, we can say, crux of this structure analysis course. So if somebody asks you that why you are doing the structure analysis, so you should be able to tell them that what are the basic necessities, what is the significance of this course, and how it differs from the designer structure course. Second point, we can here in structure analysis, we assume dimensions, loads could be given, but dimensions and material properties, since we are doing analysis in one dimension, let me add some other participant also. Okay, material properties and support conditions. Whereas in design, we start with selection of materials, whether it would be selection of materials, uh, structure system, structure system required for the construction. So here, what we will do, we will first finalize the material, that whether we are using M20 concrete, M30 concrete, M40, and many more, and what kind of steel we are using, either it is Fe250 or Fe415 or Fe550D. Based upon the strength of the material available, we will calculate the required material amount that we need it to be calculated. Third, we can say here analysis was involves study on the basis of strength, stiffness, and stability. Whereas in structural design, study is carried out on the basis of, let me rub this off. Study is carried out on the basis of serviceability, safety, and durability. So these are all the points which differentiate between the structure analysis and the design of structures course. So here I have told you that if we have different kinds of supports, like we have say this is hinge support, how many reaction will be there. You have to remember this, because then only you will be able to solve the questions coming up, coming in this slides also, and also in the coming weeks, where you have to see that you don't have to remember, you just have to see that in hinge how much constraints are there. That you can also see the door hinge also, where it is restraining the movement, displacement in x and y direction, but it is allowing the door of your room to rotate about a particular axis. So the here rotation is the degree of freedom. Whereas in roller support, you have only the vertical support you are providing. The horizontal movement and the rotation of the member is allowed. Whereas in fixed support, nothing is allowed. That's why it is called as fixed. So this is internal hinge. Then you have guided roller and many more supports are there, which will get complex as the structure complexity increases. So this is what we have discussed about degrees of freedom of all the three kinds of structure: fixed, hinge, and roller. and this is how we design. You don't have to give too much stress on this because this is not the part of your syllabus that you have to do in this particular course. Now, this is your syllabus that you have to cover in all the coming weeks, around 12 weeks course. So I think you have seen in the videos also, it is a 12-week course where you have to learn about equilibrium, stability, determinacy of the structure, shear force and bending moment diagrams. Then in next coming week, I think sir will start about the determinate structures, plain truss using method of joints and method of section. Then you will see how the deflection of truss will be calculated using method of virtual words. Then from truss we will move to deflection of beams and frames. So how we will calculate? So you will calculate this by using moment area method, conjugate beam method, virtual work method that will be covered in fourth and fifth week. And then you have influence line diagram. What is influence line diagram is that suppose you have a moving train over a bridge. So what kind of reactions and bending moments are developed at different support due to this movement due to this moving load of the train, we will try to analyze in this section. Then we have indeterminate structures. Here we will see two kinds of a method. One is the force method and another is stiffness method. Then we use method of consistent deformations also, moment distribution method, slope deflection method, and finally we will introduce you to the direct stiffness method that is required to analyze the structure. So this is the whole syllabus. Here we can see you have only analyze the structure. You have to find the reactions that are developed at different supports, and based upon the kind of the frames, truss, beams that are involved in different kind of members. You don't have to design a structure. You have to just, based upon the loading, what will be the reaction at different supports that you have to calculate by various methods. It will not differ that whether you calculate by moment area method or conjugate beam method, the answer will differ. Only the techniques are different that you can use to solve and analyze a problem based upon your convenience and the problem requirement. So this is the whole syllabus. Now, first, since currently you have done the full basic course from for the week one, where you have seen how the display how the bending moments of the and the shear force diagram are drawn, and now I will show you some questions, basic questions, that how to solve them and that you can use in solving the problems that you have given to you for the assignment one. This is the whole purpose of this class, to make the students aware that how we can approach a problem and try to solve them as easy as possible. So first question is, what is the distance of the center of gravity of a right angle triangle along the adjacent from the opposite? Adjacent means base and from the opposite means height. Now I will first differentiate what is the difference between centroid and center of gravity. So centroid we generally define as a, let me take it. Centroid we generally define it as a, it is a single point about which the entire area of the body is acting.
Whereas in
Whereas in
center of
center of
gravity,
gravity,
it is
it is
also a
also a
point,
point,
but you will
but you will
see
see
that it is
that
a
it is a
point in
point in
3D
3D
or
or
the
the
3D
3D
domain,
domain,
about
about
which
which
the
the
entire
entire
weight.
weight.
Please
Please
concentrate here
concentrate here
that it is
that
not
it
the
is not
entire
the
area.
entire
Here
area.
it is
Here it
entire
is
weight,
entire weight,
which is the
which
only
is the
point of
only
the
point of the
difference
difference
here
here
between the
between the
centroid and the
centroid and
center
the
of
center of
gravity.
gravity.
Another thing
Another thing
that is
that
there,
is there,
that
that
it is
it is
applicable
applicable
to
to
plane
plane
figures
figures
having
having
area
area
but
but
no volume.
no volume.
So what kind
So
of
what kind
figures
of
are
figures
these?
are these?
So it
So
means
it
these
means
are
these are
2D
2D
shapes.
shapes.
So
So
what are the
what are the
examples for
examples
them?
for them?
These are
These are
rectangle,
rectangle,
square,
square,
circle,
circle,
semicircle,
semicircle,
triangle,
triangle,
quarter
quarter
circle,
circle,
and many
and
more.
many more.
Whereas in
Whereas in
center of
center of
gravity,
gravity,
it is
it is
only
only
applicable
applicable
for
for
those
those
bodies
bodies
which
which
have
have
mass
mass
or
or
volume.
volume.
So what
So
kind
what
of
kind
bodies
of
are
bodies
these?
are these?
So these
So
are
these are
3D
3D
shapes.
shapes.
So what
So
are the
what are the
3D
3D
shapes?
shapes?
3D shapes
3D
could
shapes
be
could be
cylinder,
cylinder,
sphere,
sphere,
cone,
cone,
cube,
cube,
hemisphere.
hemisphere.
So this
So
is the
this is the
basic
basic
difference
difference
that
that
centroid is
centroid is
applicable
applicable
where we
where we
have
have
2D
2D
shapes,
shapes,
whereas center
whereas
of gravity
center
is
of gravity is
applicable where we
applicable
have
where we
3D
have
shape.
3D shape.
Here the
Here the
centroid is
centroid is
the
the
single
single
point
point
in which the
in which the
entire area
entire
of the
area
body
of
is
the body
acting,
is acting,
whereas
whereas
in
in
CG it is
CG
the
it is the
entire
entire
weight
weight that is
of the
of the
body
body
that
that
is
is
acting over
acting
a
over
single
a
point.
single point.
So this is the
So this is the
common
common
difference
difference
in between
in
the
between the
CG
CG
and the
and the
centroid of the
centroid of
section.
the section.
But
But
generally, since
generally,
we are doing
since
the
we are
mostly are
doing
doing 2D
the mostly are
analysis,
doing 2D
suppose we
analysis,
have to
suppose
find
we have to
the
find the
CG of
CG
this
of this
eye
eye
section.
section.
This eye
This eye
section
section
would be
would be
very much
very
long
much
in
long
length.
in length.
So
So
suppose this is the
suppose
eye
this is the eye
section.
section.
Then
Then
how you
how
will
you
make?
will make? You will take
You will
you will
analyze the
analyze
cross
the cross
section.
section.
You will
You will
take
take
the cross
the
section
cross
of the
section of the
body
body
and try
and
to
try to
find
find
its CG,
its CG,
either about major
either
axis or
about
about
major
minor
axis or
axis.
about minor axis.
So this is
So
how
this
you
is
will
how
do.
you will do.
Now talking about
Now
this
talking about
question,
this question,
let me raise
let
this.
me raise this.
Then it will be
Then it
that
will be
I will
then
show
I
you
will show you
on that how
that
to
how
solve
to
this.
solve this.
So
So
you have a
you have a
triangle,
triangle,
right angle
right angle
triangle.
triangle.
It is not
It is
making.
not making.
So this is your
So
right
this is your
angle
right angle
triangle.
triangle.
So
So
where you
where you
want to
want to
calculate
calculate
the
the
coordinate axis
coordinate
also
axis
you need
also
to
you need
define.
to define.
So suppose
So
I am
suppose I
defining
am
the
defining
coordinate
the coordinate
axis
axis
along the
along
base
the
of the
base of the
section,
section,
starting from
starting
here.
from here.
So see,
So see,
this is the
this is the
coordinate
coordinate
axis
axis
X and Y.
X and Y.
So
So
how you will
how you will
define?
define?
For right
For
angle
right angle
triangle,
triangle,
it is
it is
defined at
defined
a
at a
distance of
distance
L
of
by
L
3
by 3
from the
from the
perpendicular side.
perpendicular side.
Please
Please
remember,
remember,
for a
for
right
a
angle
right angle
triangle,
triangle,
I think
I
you
think you
must have
must
learned
have
all of
learned
this
all of this
in
in
strength of
strength of
material course
material
also.
course also.
If you're not,
If you're
you
not,
can
you can
see here also.
see here
For
also.
a right
For
angle
a right angle
triangle,
triangle,
the
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 centroid.
centroid.
Here it is a
Here it is a
2D
2D
body, so
body,
we
so we
don't
don't
call
call
them as
them as
a
a
center of
center of
gravity. We
gravity.
can
We can
also call it
also
as
call it as
centroid.
centroid.
The
The
centroid of the
centroid of the
body
body
lies
lies
at a
at a
distance of
distance of
L by
L
3.
by 3.
Since
Since they have mentioned it as the
the whole
other
length
whole
to be
length to
L,
be L,
so at a
so at a
distance of
distance
L
of
by
L
3
by 3
from
from
vertical.
vertical.
Please
Please
remember, if
remember,
you are
if you are
taking
taking
it
it
from this
from this
side,
side,
then it will
then it
be
will be
2L by
2L
3.
by 3.
Always
Always
remember
remember
this thing,
this thing,
because you
because you
also,
also
in
in
further
further
thing,
thing,
you
you
also
also
require
require
this
this
to
to
calculate the
calculate the
reaction when
reaction
you
when
have
you
a
have a
uniformly
uniformly
varying load.
varying load.
So suppose
So
if you have
suppose
a
if you have a
uniformly
uniformly
varying load,
varying load,
okay,
okay,
if you
if
have
you
a
have a
uniformly
uniformly
varying
varying
load,
load,
you will
you will
convert
convert
this
this
whole
whole
load
load
into
into
equivalent
equivalent
point load.
point load.
And this
And this
point
point
load,
load,
if this
if this
distance is
distance is
L
L
and this
and
hole
this
is
hole is
L,
L,
it will
it
be
will be
acting at a
acting at a
distance
distance
of
of
L by
L
3
by
from
3
this
from
side,
this side,
not this
not
side.
this side.
There it
There
would
it
be
would be
2L by
2L
3.
by 3.
Okay,
Okay,
please
please
write it
write it
carefully,
carefully,
because
because
maybe my
maybe my
handwriting is
handwriting
not
is
too
not
good
too
for
good for
you
you
to see
to
that.
see that.
So
So
this is the
this is
main
the main
difference
difference
you have
you have
seen for
seen
the
for the
centroid,
centroid,
that how
that
we
how we
start
start
with
with
centroid and
centroid
center
and
of
center of
gravity.
gravity.
What is the
What is the
major
major
difference
difference
between both
between
of
both
them?
of them?
How you
How
try
you
to
try to
analyze the
analyze the
problem,
problem,
and these
and
are
these
the
are the
journal
journal
values
values
that you
that
will
that you
should
should
learn
learn
for
for
various
various
CG.
CG.
So please
So
see,
please see,
for
for
cylinder,
cylinder,
the
the
position of
position of
this
this
center of
center of
gravity is
gravity
at a
is at a
distance of
distance
h
of
by
h
2
by
from
2
its.
from its.
See,
See,
this
this
will be,
will be,
if you have a
if you have a
cylinder,
cylinder,
you have
you
a
have a
CG at a
CG at a
distance of h
distance
by
of h
2.
by 2.
Now,
Now,
if you have
if
a
you have a
sphere, it
sphere,
is at a
it is at a
distance of
distance
r.
of r.
But
But
nowadays we
nowadays we
don't
don't
use
use
r, we
R, we
use
use
d by
d
2.
by 2.
So please
So
try
please
to
try to
remember in the
remember in
terms
the
of d
terms
by
of d
2
by 2
all the
all the
formulas,
formulas,
whether it
whether it
is
is
this,
this,
either it
either
is
it is
moment of
moment of
inertia,
inertia
or it
or
is
it is
section
section
modulus.
modulus.
Try to
Try to
remember in
remember
terms
in
of
terms
dy
of d by in
diameter
diameter
terms.
terms.
It will be
It will
easy
be
for
easy
you
for
for the
you for
later
the later
calculations.
calculations.
For
For
hemisphere it is
hemisphere, it is
3r by
3r by
8.
8.
For
For
cone it
cone,
is at a
it is at a
distance of
distance
h
of
by
h by
4.
4.
And for
And for
pyramid
pyramid
also it is
also, it
at a
is
distance
at a
of h
distance
by
of
4.
h by 4.
Now,
Now,
this is
this is
a
a
journal
journal
basic
basic
problem.
problem.
This is a
This is a
mechanics
mechanics
problem. I
problem.
can
I
say
can say
it is
it is
not a
not a
analysis
analysis
problem. It is a
problem. It is a
mechanics
mechanics
problem.
problem.
So what
So
this
what this
question
question
says?
says?
This question
This
says
question
that
says
the
that
force
the
of
force
30
of 30
kilonewton and
kilonewton
50
and 50
kilonewton
kilonewton
act on a
act on a
bracket.
bracket.
This is a
This is a
bracket.
bracket.
This is
This is
bracket.
bracket.
As shown in
As
the
shown in the
figure.
figure,
What is the
what is the
magnitude of the
magnitude of the
resultant force
resultant force
acting
acting
on the
on the
bracket?
bracket?
So you
So
have
you
to
have to
find the
find the
resultant
resultant
force.
force.
So
So
how you
how
have
you have
learned
learned
that
that
how you
how
will
you will
calculate the
calculate the
resultant force?
resultant force?
If you
If you
have
have
a
a
force
force
in
in
two
two
directions,
directions,
that is,
that
it
is,
is
it is
split
split it
into
into
RV
RV
and
and RH.
Then how you
Then
will
how you will
determine
determine
R?
R?
How you
How you
determine this
determine
R?
this R?
So you
So
can
you can
determine this
determine
R
this R
as,
as,
let me
let me
remove this.
remove this.
Mm,
Hmm.
some people
Some
are
people
again
are again
coming.
coming.
Let me
Let
add
me
them.
add them.
Yeah.
Yeah.
So everyone,
So
please
everyone,
try to
please
come in
try
the
to come in the
class at
class
time,
at time,
because the class
because the
starts
class starts
at
at
4 a.m.
4 a.m.
4 p.m.
4
Sorry,
p.m.
not
Sorry,
4
not
a.m.
4 a.m.
And
And
you try
you
to
try
be
to
in
be in
before
before
3:55
3:55
until 4,
and till 4,
because after
because
that
after that
every
every
time I have to
time I
see
have
in
to
the
see in
window
the
that
window that who are
in
in
the
the
section, and
section, and
I have to
I have
admit
to
them in
admit
the
them in the
class.
class.
Not a worry,
Not a worry.
we will
We
continue
will
further.
continue further.
We will
We will
calculate the
calculate the
resultant
resultant
force
force
using
using
RH
RH
square
square
plus
plus
RV
RV
square
square
plus
plus
2 RH
2RH
RV
RV
cos of
cos
theta.
of theta.
Theta is
Theta
the
is the
angle
angle
between
between
the
the
two
two
vectors,
vectors,
that is
that is
RH and
RH and
RV,
RV,
from where
from
you
where
have
you
to
have to
find the
find the
resultant. So
resultant.
this
So
is
this
your
is your
resultant
resultant
force.
force.
So this is
So
your
this is your
resultant
resultant
force.
force.
You need
You
to
need to
find
find
the
the
reactions
reactions
in this.
in this.
So
So
for this
for
you
this
have
you have
to
to
use
use
equations of
equations of
equilibrium.
equilibrium.
Using
Using
equations of
equations of
equilibrium,
equilibrium.
so here
So
we
here
have
we
three
have three
equations:
equations.
sigma
Sigma
h,
h,
that is sum
that is
of
sum of
horizontal force
horizontal
is
force
equal
is
to
equal
0,
to 0.
that is
That is,
this
this
force is
force is
equal to
equal to
this
this
force.
force.
Sigma
Sigma
v is
v
equal
is
to
equal to
0,
0.
that is
That is
vertical
vertical
force
force
upward
upward
and
and
downward are
downward
equal
are
to
equal to
0.
0.
And
The
third is
third is
moment is
moment
equal
is
to
equal
0,
to 0.
that is
That is
anti-clockwise
anti-clockwise
moment is
moment
equal
is
to the
equal to the
clockwise
clockwise
moment.
moment.
Currently
Currently,
you have to
you
take
have to
only
take only
directions,
directions,
and
and
signs
signs
differ
differ
based upon
based
the
upon the
convention we
convention we
use.
use.
So I
So
will
I
copy
will copy
this
this
diagram and
diagram
will
and will
try to
try
solve in
to
the
solve in the
next
next
slide.
slide.
So yeah,
So yeah,
this is our
this is our
diagram.
diagram.
So here it
So
is of
here it is
fixed
of
support.
fixed support.
Since no
Since
moment
no
is
moment is
acting,
acting,
I will
I will
take
take
only the
only the
reactions.
reactions.
So I am
So I am
taking
taking
here
here
the
the
vertical
vertical
reaction
reaction
and the
and the
horizontal
horizontal
reaction. So
reaction.
this
So
is
this
my
is my
RH,
RH,
this is my
this is my
RV.
RV.
Now
Now,
using
using
sigma h
sigma
equal
h
to
equal
0,
to 0,
please see
please
this
see this
carefully. We
carefully.
have this
We
30
have this 30
kilonewton
kilonewton
at an angle
at
of
an angle
15
of
degree.
15 degree.
So in
So in
horizontal it would
horizontal,
be
it would be
30
30
cos
cos
15.
15.
We also
We
have
also have
15 degree,
15 degree,
15
15
kilonewton in the
kilonewton
angle
in
of
the
30
angle of
degree.
30
So it
degrees.
will
So
be
it will be
15
15
cos
cos
30.
30.
That will be
That
equal
will be
to,
equal to, uh,
sorry,
sorry,
here it will be a
here it will
negative
be a
sign,
negative sign,
and plus
and
we will
plus
be
we will
having,
be having, let
let me
me
have given
have
drawn
given drawn
conventions.
conventions.
This is
This
our
is our
RH,
RH,
this is our
this is our
RV.
RV.
So
So
this would be
this would be
RH.
RH.
yeah,
Yeah. Uh,
yeah.
yeah.
This would be
This
RH.
would be
No,
RH.
now
No.
it is
Now
correct.
it is correct.
Yeah,
Yeah.
now it is
Now
correct.
it is correct.
So
So
solving this,
solving this,
please solve with
please
me
solve with me
at what
at what
value you are
value you
getting.
are getting.
I am
I
getting
am
it as
getting it as
30
30
cos
cos
15
15
plus
plus
15
15
cos
cos
30.
30.
So the
So
value is
the
coming
value is
out
coming out
around
around
41.968
41.968
kilonewton.
kilonewton.
Again,
Again,
we also
we
have to
also have to
calculate
calculate
vertical
vertical
reaction.
reaction.
So how you
So
will
how we will
calculate the
calculate the
vertical
vertical
reaction?
reaction?
So here
So
the
here
30
the 30
kilonewton vertical
kilonewton vertical
reaction is
reaction is
30 sine
30 sine
15
15
minus
minus
15 also
15
we
also
have
we have
15
15
sine
sine
30
30
plus
plus
RV
RV
is equal
is
to
equal
0.
to 0.
This
This
implies what
implies
is the
what
value
is
of
the value
RV?
of RV?
It will
It
be
will be
15
15
sine
sine
30
30
minus
minus
30
30
sine
sine
15.
15.
So
So
yeah,
yeah,
I am
I
also
am also
getting this
getting this
value
value
around
around
26.26
26.26
for
for
6
6
kilonewton.
kilonewton.
I am
I am
getting this
getting this
negative
negative
sign.
sign.
This
This
negative
negative
sign
sign
indicates,
indicates,
let me
let
write
me
it.
write it.
This
This
negative sign
negative sign
indicates
indicates
that
that
my
my
assumed
assumed
direction,
direction,
that the
that the
force
force
is
is
acting
acting
opposite
opposite
to my
to my
assumed
assumed
direction.
direction.
But that is
But
not,
that is not,
but that will
but that
not
will not
differ my
differ
answer.
my answer.
So
So
finally,
finally,
resultant
resultant
force
force
will be
will be
resultant
resultant
force
force. What's happening?
so
So yeah,
resultant
resultant
force
force
R will
R
be
will
under
be
root
under
of
root of
Rx square
Rx square
plus
plus
RV
RV
square
square
plus
plus
2
2
Rx
RH
RV.
RV.
What is the
What
angle
is the
in
angle
between
in
them?
between them?
So angle
So
between
angle
them is
between them is
90. So
90.
toss
So
90.
toss 90.
So
So
this
this
vanish off
vanish off
because toss
because
90
toss
is
90 is
0.
0.
So we
So
have
we
R
have R
equal to
equal
under
to
root
under
of
root of
Rx
Rx
square
square
plus
plus
RV square.
RV square.
Please solve
Please
this
solve
and
this and
provide me the
provide me the
answer.
answer.
So here
So
R is
here
coming
R is
out to
coming
be
out to be
41.96
41.96
kilonewton.
kilonewton.
Yeah,
Yeah,
this is the
this
answer.
is the answer finally.
Let's move to the
Let's move to
next
the next
question.
question.
We have a
We have
next
a
question
next
as
question as
what will be the
what will be the
bending moment
bending
at the
moment
fixed
at the
support
fixed
of a
support of a
cantilever
cantilever
beam
beam
of length
of
L
length L
subjected to a
subjected to a
uniformly
uniformly
distributed
distributed
load of
load of
intensity
intensity
W per
W
unit
per
length
unit length
over
over
its whole
its
length.
whole length.
So
So
this is
this is
how
how
we
we
define a
define a
cantilever beam.
cantilever beam.
It is
It is
subjected to a
subjected to a
uniformly
uniformly
distributed
distributed
load
load.
so it is
So it
having
is
a
having a
length
length
L.
L.
Yeah,
Yeah,
this is the
this is the
length.
length.
Now we
Now
have
we
to
have to
find out the
find out
bending
the
moment at
bending
the
moment
fixed
at the
end
fixed
support.
end support.
So what will be the
So what will
bending
be the
moment
bending
here?
moment here?
This moment.
This moment.
This moment we
This
need to
moment we need to
calculate.
calculate.
So
So
how you
how
will
you will
calculate?
calculate?
So
So
this we can
this we
say,
can say,
suppose
suppose
this is the
this is
whole
the whole
load
load
W
W
per
per
meter.
meter.
So
So
if we convert
convert
the
the
whole
whole
load
load
into
into
equivalent
equivalent
load,
load,
it
it
will
will
be
be
W
W
into
into
L
L
acting over the
acting over the
section,
section,
and we have to
and we have
find
to
it
find it
at the fit
at the
support.
fit
So this
support.
is
So
our
this
fit
is our
support.
fit support.
What is the
What is the
formula for
formula
bending
for
moment?
bending moment?
Bending moment
Bending
is
moment is
defined as
defined as
the
the
load
load
which is
which is
acting,
acting,
that is the
that is the
force,
force,
multiply by
multiply
the
by the
lever arm
lever arm
distance, that
distance,
is
that is
this lever
this
arm
lever arm
distance.
distance.
Distance
Distance
between
between
point of
point of
application of
application of
load
load
and
and
where
where
the load is
the load is
applied,
applied,
where
where
the low,
the low,
the
the
bending moment,
bending moment,
where
where
bending
bending
moment
moment
is to
is
be
to be
calculated.
calculated.
So that
So
is
that is
WL
WL
into L
into
by
L
2.
by 2.
It will be
It will
equal
be
to
equal to
WL
WL
square by
square
2.
by 2.
Please note
Please note
here
here
that
that
it will be
it will be
useful for
useful
you,
for you,
but try to
but try to
remember what I
remember
am
what I am
saying,
saying,
that
that
this
this
bending
bending
moment
moment
in
in
UDL
UDL
is in
is in
square
square
form
form
or
or
quadratic form.
quadratic form.
Not I will
Not
write
I will
it
write it in
quadratic form.
quadratic form.
So
So
here
here
the
the
bending moment
bending moment
diagram,
diagram,
that is
that
bending
is
moment
bending moment
diagram,
diagram,
will
will
not
not
be
be
linear.
linear.
Okay.
Okay.
So
So
using this
using this
formula, you
formula,
can
you can
remember this,
remember
that
this, that
it
it
will
will
help you
help everyone
understand
understand
that here
that
the bending
here the
moment
bending
diagram will
moment
not be
diagram will
linear.
not be linear.
Now next
Now
question.
next question.
You have to
You have to
calculate
calculate
the vertical
the vertical
reaction
reaction
at the
at
joint
the
A in the
joint A in
figure
the figure
under the given
under the
loading
given loading
condition.
condition.
So please
So please
try to
try
make
to make
the
the
free body
free body
diagram
diagram
for this
for
beam.
this beam.
Yeah.
Yeah.
So this is a
So this is a
beam.
beam.
Here the
Here
load
the
is
load is
acting.
acting.
I will
I will
convert
convert
this
this
load
load
into a
into a
point load
point load
acting
acting
over it.
over it.
So what will
So
be the
what will be
value
the
of this
value of
load?
this load?
So
So
here this
here this
point load
point
value
load value
is,
is,
you have to
you have
calculate
to
the
calculate
area,
the
that
area,
is 1 by
that is 1
2
by 2
into
into
30
30
into what will be
into
the
what will be
length.
the length.
It is spread
It is
over the
spread
length
over
of
the length
2.
of 2.
So here
So
the
here
value
the
comes
value
out to
comes
be
out to be
30
30
kilonewton.
kilonewton.
So
So
I have
I have
converted
converted
the
the
load
load
acting
acting
over
over
acting over
acting over
the
the
beam
beam
as
as
uniformly
uniformly
varying
varying
load
load
into a
into a
point
point
load
load
by
by
taking the
taking the
area of
area of
this
this
loading
loading
diagram,
diagram,
and then
and
we
then
will
we will
also have to
also have to
define the
define the
position.
position.
So
So
it
it
will be
will be
acting at
acting
a
at a
distance of
distance of
1 by
1
3
by
of
3 of
2,
2,
that is
that is
0.66 meter.
0.66 meter.
So
So
now
now
what will be
what will
this
be this
distance?
distance?
This will be
This will be
5
5
minus
minus
0.66
0.66
meter.
meter.
Okay.
Okay.
Therefore,
Therefore,
taking what
taking what
sigma b
sigma
equal
b
to
equal to
0,
0,
suppose
suppose
this is
this
your
is your
RA,
RA,
this is your
this is your
HA,
HA,
which will be
which will
equal
be
to
equal to
0.
0.
So here
So here
RA
RA
is equal
is
to
equal to
30
30
kilonewton.
kilonewton.
Hello, sir.
Yes.
Yes.
Sir, why we multiply by half?
Half we
Half we
is
is
multiplying because
multiplying
C,
because C,
you have
you
to
have to
take it as
take it
a
as a
loading diagram
loading
area.
diagram area.
So this is
So this
a
is a
triangle.
triangle.
How
So
you
how you
define the area
define
of
the area
triangle?
of
1
triangle?
by
1
2.
by 2. into length, the base. We have base as 2,
and what will
and
the
what will the
loading
loading
is
is
30.
30.
So that
So
turns out
that
to be
turns out to
30
be 30
kilonewton.
kilonewton.
Is it
Is
fine?
it fine?
Hello.
Hello.
Who is
Who is
asking this
asking this
question?
question?
Yes, sir.
Yeah.
I
Yeah.
understand.
Yeah. If
Yeah.
you have
If
a
you have a
UDL, na,
UDL, na,
if you have a
if you have a
UDL,
UDL,
then you
then
don't
you don't
have to
have to
make it
make it
multiply by
multiply
2.
by
Then
2.
you can
Then you can
simply
simply
make it as
make it as
2 into
2 into
30. That
30.
would be
That would
60
be 60
kilonewton.
kilonewton.
But
But
here
here
you have
you
to
have to
convert,
convert, if you have to convert the
point load
point load
into
into the
the UVL into a
UVL into a
point load.
point load,
You have
you
to
have
take
to
the
take the
area of the
area of the
of the
of the
moment
moment
of the
of
loading
the loading
diagram.
diagram.
So I will
So I
erase
will
this
erase
now.
this now.
So yeah,
So yeah,
this is your
this is your
final
final
answer.
answer. Now suppose also you, if you can also calculate the moment also at the fixed end. If you also have to calculate the moment,
So how you
so
will
how you
define
will
the
define the
bending
bending
moment
moment
at
at
the
the
fixed
fixed
end?
end?
So if you
So if
also
you
have to
also have
find the
to find the
bending
bending
moment,
moment,
that would
that
be
would be
30.
30. That is
Load
the load
acting over the
acting over the
surface.
surface.
Multiply by,
Multiply by,
I will give
I
you
will give
another
you another
description of the
description
how
of
to
the how to
calculate.
calculate.
3 you
3 you
already know
already
from the
know from the
figure,
figure,
plus
plus
2 by
2
3
by 3
of
of
3.
3.
No, no.
No,
2 by
2 by
3
3
of
of
2.
2.
Now you
Now
will get
you will get
30
30
into
into
3
3
plus 4 by
plus 4
3.
by 3.
That
That
will be
will be
30
30
into 13
into
by
13
3.
by 3.
That comes out
That
to
comes
be
out to be
130
130
kilonewton meter.
kilonewton meter.
Does
Does
anyone
anyone
have doubt
have
in
doubt
this
in
that
this,
how
that
I
how I
calculated this?
calculated this?
No,
No,
it's fine.
it's fine.
So how I
So how I
calculated this?
calculated
3
this?
you
3
know
you know
from this
from
that
this,
this
that
is 3
this is 3 3
meter
meter
distance.
distance.
Yeah,
Yeah,
this is a
this
3
is a
meter
3 meter
distance.
distance.
So that 1 by 3.
No, no.
No,
Here
here
suppose we
suppose
have to
we have to
calculate here
calculate
the
here the
distance from
distance
this
from
side is
this
1 by
side is
3.
1 by 3.
Yeah,
Yeah,
this
this
distance is 1
distance
by
is
3.
1 by 3.
But from
But
other
from
side
other
it is
side
2
it
by
is 2
3.
by 3.
That you have to
That you have
remember
to
that
remember,
which
that
side you
which
are
side you are
choosing.
choosing.
That's why
That's
I
why
have
I have
not
not
taken
taken
directly
directly
5
5
minus
minus
0.66
0.66
meter.
meter.
That's why I
That's
have
why I have
written it as
written
2
it
by
as 2
3.
by 3.
If you write
If
it
you
as
write it
2
at
by
2 by
3,
3,
then 2 by
then 2
3
by 3
multiply by the
multiply by the
length
length
will
will
give you
give you
the
the
value of
value
this
of
thing.
this thing.
Yeah.
Yeah.
So if
So
I
if
am
I am
taking the
taking
load
the
here,
load here,
this
this
will be
will be
2 by
2
3
by
of
3 of
2,
2,
and
and
this will be
this will
1
be
by
1
3
by
of
3
2.
of 2.
I will
I
write
will
it
write
here.
it here.
1 by
1
3
by
of
3
2.
of 2.
So we are
So we
considering
are
the
considering the
distance from this
distance from
side.
this side.
This is our
This is our
distance.
distance.
So here
So here
it will be
it will be
3
3
plus 2
plus
by
2
3
by
of
3 of
2.
2.
This will
This will
us
give us
the
the
13 by 3
13
which
by
is the
3, which is the
distance,
distance,
and
and
here
here
we
we
have the
have the
moment turns
moment
out to
comes
be
out to be
130
130
kilometer meter.
kilometer meter.
Now it's fine.
Now it's fine.
Let's continue
Let's
further.
continue further.
So fifth,
So fifth,
another question
another
we
question we
have
have
is that
is that
what will be
what
the
will be the
section
section
modulus
modulus
of a
of a
square
square
section
section
about an
about an
axis
axis
through its center
through
of
its center
gravity.
of gravity?
So we have
So we
already
have already
seen that
seen
what
that
if
if
the
the
we
we
have
have
to
to
see
see
what will be the
what will be the
CG.
CG.
See,
CG.
this is
See,
the
this is
CG.
the CG.
And you
And
have to
you have to
calculate
calculate
the
the
section
section
modulus.
modulus. So
First,
first,
try to
try
see
to
what
see
is
what
CG.
is CG.
CG, sorry.
Sorry.
Try to see what
Try
is
to see what is
section
section
modulus.
modulus.
So
So
section
a
modulus
section
is a
modulus is a
geometric
geometric
property of a
property
given
of a
cross
given
section,
cross section,
whether
whether
it
it
would
would
be
be
rectangle,
rectangle,
square,
square,
triangle,
triangle,
and
and
sphere,
sphere,
not sphere,
not sphere,
circle,
circle, that is used in the design of for the beam or flexural members. So since it is a geometric property, we can define it by any two variables. So the variable that are used to define the section modulus are I and y, where I is the second moment of area, or you can also call it to be moment of inertia, because generally the second moment of area is inertia. First moment of area we call it as centroid, and y is the distance from the neutral axis to the given fiber. So for the rectangle, see this figure, we have this axis. We know how to calculate the rectangular moment of inertia. So how we calculate it as, suppose I am calculating about vertical axis, then I y y, I say it as y axis. Okay, what will be the I y y? It will be b h cube divided by 12. This is your moment of inertia. Now how we will define y? Y will be the this distance from the center. What will be the distance of the outermost fiber, this fiber till this point, that is h by 2. So here s or z, I will write it as z, because this is a journal convention we will use. I will also change here to z. Okay, so z is I by y, here bh cube upon 12 divided by h by 2. It will be bh square upon 6. See, this is how you will calculate for the rectangular section. And here the question asked for square. How you will do that? You will equate, now s is equal to dh square upon 6 for square, b is equal to h. Suppose it is equal to a, therefore s will be equal to a cube upon 6. Yeah, this is how you will calculate section modulus for a square section. Now these are the journal formulas that you can use. Some of them you can remember also, that you can remember for rectangle how the section modulus is defined, and some you can derive also based upon the complexity of the problem. So yeah, for circle you can remember is as pi d cube upon 32. Here how you find it as, because I is equal to pi d power 4 upon 64. This is I, and here y is equal to d by 2. So s is equal to I by y, that will be equal to pi d power 4 upon 64 divided by d by 2. That will give you pi d cube upon 32. So similarly, for double symmetric sections, we can find out uh, the section modulus about major axis as well as about minor axis. So when there is circular section, how you will define? When you will have the rectangular hollow section, how you will define? For channel section, how you define? Generally, you don't have to be in this course much be worried about this, because you only require either rectangle, square, or circle. Sometimes, based upon the complexity, it could be double symmetric section also, either about major and minor axis. Now let's move forward. This is a question, I think this might be covered in this week's course, that how you will calculate the force in the member of a truss. So I will give you only a uh,
how
how
you
you
in
in
trust. What
trust.
is the
What is the
difference between a
difference between a
trust member
trust
and
member
a
and
beam
a
member?
beam member?
The only
The
difference
only
between a
difference
trust
between a
member
trust
and
member
beam
and
member
beam
is
member is
that
that
in trust
in trust
member,
member
no
no
bending
bending
moment is
moment
there.
is there.
Please
Please
remember,
remember,
no
no
bending moment
bending
is
moment
there
is
in
there in
trust,
trust,
whereas in
whereas in
B,
B
you have
you
the
have the
bending
bending
moment
moment
at
at
each
each
and
and
every
every
location.
location.
Whereas in
Whereas
trust
in
member,
trust
you
member you
only
only
calculate
calculate
compression.
compression.
We will
We will
say the
say the
member is
member
either is in
either is in
tension or
tension
in
or in
compression.
compression.
So these
So
are the
these are
general
the general
properties of a
properties of a
trust member.
trust member.
Now talking
Now
about
talking
this
about this
problem,
problem,
here it is
here it is
mentioned
mentioned
that
that
the
the
force of,
force of a
in the
in the
member
member
dB, this
dB,
member,
this member,
uh,
uh,
this member,
this member
you have to
you have to
calculate,
calculate,
and
and
given
given
as
as
LA
LA
and
and
LB and
LB and
LC are
LC are
equal.
equal.
That is,
That is
this
this
side, this
side, this
side, this
side,
side
this
are
side are
equal.
equal.
So
So
now
now
apply
apply
moment of
moment
section.
of section.
I
I
think you
think
don't
you
know.
don't know.
Currently, you
Currently, you
might have
might have
not
not
read
read
in
in the
this,
this
that how
that
you will
how you will
calculate.
calculate,
But
but
still, I will
still I
show
will
you.
show you.
You please
You
see.
please see.
So
So
you will
you
cut
will
a
cut a
section,
section
and you
and
will
you will
assume the
assume the
whole
whole
member to
members
be
to be
tensile.
tensile.
So
So
at
at
joint
joint
A,
A,
so this
so
is
this
method
is
of
method of
joint.
joint.
Let me
Let me
write
write using
this.
this.
So at
So at
joint
joint
A,
A,
you
you
have
have
reaction
reaction
RA.
RA.
So
So
since the
since
member
the
is
member is
symmetrical,
symmetrical,
reaction will
reaction
be
will be
equal
equal
in both
in
the
both the
cases. It
cases.
will be
It
P
will
by
be P
2 and
by
P
2
by
and P
2.
by 2.
So here
So here
RA will be
RA will
equal
be
to P
equal to
by
P
2.
by 2.
You
You
have two
have two
forces,
forces,
FAC,
FAC,
FAB.
FAB.
Okay,
Okay.
apply
Apply
for equilibrium
equilibrium
principle.
principle.
You will
You will
have
have
sigma b
sigma
equal
B
to
equal to
0.
0.
You will
You will
have
have
FAC
FAC
sine
sine
60.
60.
Now how
Now, how
60 came
60
here
came
is
here is
because all the
because all
three
the
sides
three
are
sides are
equal, so
equal,
each
so
angle
each
is
angle
60
is
degree.
60 degree.
FAC
FAC
60
60
plus
plus
P by
P
2,
by 2,
that will be
that will
equal
be
to
equal
0.
to 0.
So
So
FAC
FAC
will be
will
equal
be
to
equal to
P by
P by
2
2
upon
upon
sine
sine
60.
60.
That will be
That will
equal
be
to
equal to
minus sign will
minus
be
sign will
there,
be there,
minus P by
minus
root
P
3.
by root 3.
Also,
Also,
you will
you
have
will have
horizontal force
horizontal
is equal
force is
to
equal
0.
to 0.
This
This
implies
implies
FAC
FAC
cos
cos
60
60
plus
plus
FAB.
FAB.
Since there
Since
is
there is
nothing
nothing
about
about
reaction in
reaction in
horizontal
horizontal
direction, so
direction,
it will
so
be
it will be
also equal
also
to
equal
0.
to 0.
This
This
implies
implies
minus P
minus
by
P
root
by
3
root 3
into
into
cos
cos
60
60
plus
plus
FAB
FAB
equal to
equal
0.
to 0.
This
This
implies
implies
FAB is equal to
FAB is
P by
equal to
2 root
P
3.
by 2 root 3.
Okay.
Okay.
Now
Now
we will copy
we will
this
copy this
in next
in
slide.
next slide.
Yeah.
Yeah.
Now
Now
about
about
joint
joint
B.
B.
Again
Again,
we will
we
draw
will draw
this.
this.
So for
So for
joint B,
joint B,
this is
this
your
is your
RB
RB
equal to P
equal to
by
P
2.
by 2.
This is
This
your
is your
FBA.
FBA.
This is
This is
FBC.
FBC.
This is
This is
FBD.
FBD. These are the forces that are acting on them. So we'll calculate that. Now, using vertical, sum of vertical force is equal to 0. We have FBD plus FBC cross it, not cross, it will be sine 60 plus P by 2 equal to 0. Also, we have horizontal force equal to FBA plus FBC cos 60 equal to 0. This implies we know FBA value, then we will calculate FBC. What is the value of FBA? FBA is P by 2 root 3. So it is P by 2 root 3 divided by cos 60. So it would be P by root 3. Okay. Now use this value in calculating FBD also. So FBD will be equal to P by root 3 minus this multiply by sine 60. It will be root 3 by 2 plus P by 2 equal to 0. So it means FBD minus P by 2 plus P by 2 equal to 0. This will give you FBD equal to 0. Okay. So in this question, there would be no force in this member. Okay. So yeah, this is how you will solve the problem of trusses in the coming week, where you will have two kinds of methods. One it would be method method of joints. Second would be method of section. Okay. Now going to next question. So here this is a general question. It is you have to calculate the elongation of a straight bar which is having a length L, cross section area A, and weight W, and E is the Young modulus of elasticity of that member. He defines the member properties, which is hung from a roof due to its self weight. It's like you are hanging a rod at the ceiling of your room, and you will try to find out what will be the elongation in that member without applying on any load, just with self weight. So generally, what we do, we solve a problem when we have a rod which is attached to a fixed support, and we apply a uniaxial load at another end of the member. But here we are trying to find out what will be the elongation due to its self weight. So let's solve this problem. First, we will make a bar. So this is our bar, fixed at one end. So yeah, it is fixed at one end. We take a cross section. Suppose this is our XX section. Okay. This is our section under consideration. So what will be the weight of this bar? Okay. So weight of the straight bar below xx. You will calculate using how you will calculate multiply by density into volume. It could be any material. We take density as rho. We know that whole cross section is having the surface is having the cross sectional area of A. So we'll take A multiply by this distance x. We are not considering the whole length because we will integrate it over the whole length. So yeah, this is the weight A x into rho. Okay. Now we will find the change in length. Change in length. Change in length. How we will define delta L. Delta L is strain into L. Okay. How you will define the strain? We define it as
Load upon elongation.
yeah stress upon E multiplied by L. What will be the stress? Stress will be the this load into area. W L upon A E. Because stress I have converted into the weight that is acting divided by area. Now what is this weight? This weight is rho AX L upon AE. Okay. AA will get cancelled out. You will have rho XL upon E. Now you integrate to find the total change. You will integrate over the whole area. You will have delta L equal to integration of 0 to L rho XL upon E to dx. That would be rho L upon E will come outside. You will have H square upon 2 in the limits of 0 to L. That will be W L Q or rho L cube upon 2E. Now again, since we have the given parameter as weight, we will convert the load, the density into weight. That would be W L cube upon 2AE into L. Okay, that will come out to be WL square upon 2AE. So this is the elongation that will have in a member subjected to uh, subjected to self weight attached from a fit support. Now moving to another question. You will have a fabricated metal bar carrying axial load as shown in the figure. You have to calculate the total change in the length of the bar. Given you will have a E value around 100 GPa and area of cross section as 2000 mm square. So for that, you don't have to calculate for the whole member as a directly. You have to take each and every section separately, and then you will calculate what will be the total elongation. So you will take first AB section, then BC, then CD, then you will then you will sum up and you will try to find the total change in the length of the bar. So first of all, check whether all the forces are balanced. So here in left direction we have 50 kilonewton force. We have 200 kilonewton force. So total comes out to be 250. In right hand side we have 100 and 150. So total comes out to be 100 plus 150 comes out to be 250 kilometers. So force equilibrium is there. Now we will solve for each section. Now for AB, we will have the load acting as 50 kilonewton. So what will be the reaction here? So here the reaction comes out to be 50 kilonewton. We calculate deflection, that is PL by AE, P50 into 4 upon A. What is A? We will currently we will keep it as AE. And the end we will substitute the values. So it will be 200 upon AE. Now for section BC, take the member, see what kind of load is acting. So 100 kilonewton is acting from this side. Also the reaction that you have got here, that will also act here. So 50 is acting in the opposite direction, 50 kilonewton. So final reaction comes out to here, that comes out to be RBC, that will be minus 50 kilonewton. Then you will calculate delta L minus PL. You will find PL by AE. That would be minus 50 into 6 upon AE. It comes out around 300 upon AE. For third section, you will use this. You have, since this reaction is coming out, this will also come out to be as minus 50 kilonewton. I am not changing the direction because then you will confused that how much kind of load is acting. So what? So okay. Here 200 kilonewton is also acting at the opposite side. So my final resultant here will be, at this CD part, will be 200 minus 50. It comes out to be 150 kilonewton. So if I try to find out the displacement or the change in length, it comes out to be 150 into, here the length of the member is 2 meter, 2 upon AE. It will be 300 upon AE. Therefore total change will be 200 upon AE minus 300 upon AE plus 200 upon AE, 300 upon AE. It will be 200 upon AE. If I substitute the values, so this is 200 kilonewton. I will convert it into Newton. Okay. Then we have 100 GPa. I will first write the area. Area will be 2000 mm square multiply by okay. If you solve this, your three zeros, it will get cancelled out. So you will get the value as 1 mm. So therefore total change, I think this will be 10 power 6. Okay, fine. No, it's right. So total change will be 1 mm. So yeah, in this question, whatever is given to you, you will have to take every section, find out what will be the reaction at each interface. This. Then you will calculate what will be the change of length. If you progress further
in
in
advanced
advanced
mechanics,
mechanics,
what you will
what you will
see,
see,
there is
there
some
is some
restrictions
restrictions
also.
also.
Sometimes
Sometimes
stress is
stress
also
is also
given that
given that
here the
here the
stress
stress
should
should
not
not
exceed
exceed
200
200
megapascal.
megapascal.
Then what you
Then
have
what
to
you
do,
have to
you
do,
have
you
to
have to
take
take
the
the
stress
stress
multiplied by
multiplied by
area.
area.
Suppose it is
Suppose it is
100
100
mm
mm
square.
square.
Then you
Then you
have to
have to
apply the
apply the
force.
force.
Not
Not
the
the
directly you
directly
will
you will
take the
take the
stress at
stress
each
at
and
each
every
and every
section try
section
to
try to
solve.
solve.
Okay,
Okay,
that you will
that you will
see
see
when
when
that
that
question will
question will
come.
come.
Now
Now,
this question I
this
think I
question I
have
think I have
already
already
covered.
covered.
So
So,
suppose you
suppose you
have a
have
heel
a heel
support
support
in two
in two
dimension.
dimension.
What is the
What is the
degree of
degree of
freedom?
freedom?
So
So,
here
here
we
we
have
have
two
two
constraints.
constraints.
Constraints are
Constraints are
two.
two.
So
So,
degree of
degree of
freedom
freedom
will be
will be
one.
1.
So what
So,
kind
what
of
kind
degree
of
of
degree
freedom
of
will
freedom will
this be?
this be?
So this
So,
will
this
be
will be
rotational degree
rotational
of
degree of
freedom.
freedom.
It
It
means
means
your
your
beam.
beam,
Suppose this
suppose
is your
this is your
beam.
beam,
It can
it can
rotate.
rotate,
Can
can
rotate like
rotate like
this.
this.
It
It
maybe
maybe
have some
have some
angle of
angle of
theta
theta
a
a
here.
here,
But
but
it
it
can't
can't
move
move
in
in
either in
either
x
in x
direction
direction
or in y
or in y
direction.
direction.
Both the
Both the
directions
directions
are
are
restricted for
restricted
them.
for them.
Okay.
Okay.
Now moving
Now
to next
moving to next
question.
question.
What will be
What
the
will be the
bending
bending
moment
moment
at
at
C
C
of the
of the
cantilever beam?
cantilever beam?
So for
So for
this
this,
you have
you
to
have to
make
make
the
the
free body
free body
diagram.
diagram.
That will be
That
easy
will be
for
easy
you.
for you.
Apply 10
Apply 10
kilonewton
kilonewton
load.
load.
So this
So
is the
this is the
moment
moment
that is
that is
acting at the
acting at the
center of the
center of the
beam.
beam.
So 10
So 10
kilonewton meter
kilonewton
is
meter is
acting at the
acting at the
center.
center.
No
No
reaction is
reaction is
there.
there.
So
So
only
only
the
the
moment
moment
reaction that
reaction
is
that is
coming
coming
at the
at
fixed
the fixed
support
support
is
is
this.
this.
I will
I will make it using the
different color.
different color.
So
So
this is
this
the
is the
only
only
10
10
kilonewton meter
kilonewton
that
meter
is
that
acting.
is acting.
So how you will
So
try
how you will try
draw the
draw
bending
the
moment
bending
diagram
moment
for
diagram
this?
for this?
So you will
So you will
make it
make it
this.
this.
Yeah.
Yeah.
So
So
this would
this
be
would be
10.
10.
So this
So
would
this
be
would be
10
10
kilonewton
kilonewton
meter
meter
acting in
acting in
positive
positive
direction.
direction.
So
So
Horn
Hormone
movement is
movement
there.
is there.
And we
And
have
we
to
have to
find
find
the
the
moment
moment
at C.
at C.
So
So
moment
moment
at
at
C
C
is
is
0.
0.
Also
Also,
let's
let's
discuss
discuss
about this
about
thing.
this thing.
So
So
here
here,
please
please
see
see,
there is
there is
no
no
force that
force
is
that is
acting
acting
in this
in this
part
part
A and
A
B.
and B.
So
So
and
and
bending
bending
moment is
moment is
constant.
constant.
Further you
Further,
will
you will
see
see
that
that
shear
shear
force will
force
be
will
the
be the
rate of
rate
change
of
of
change of
bending
bending
moment.
moment.
So if
So
this
if this
moment is
moment is
constant, it
constant,
means
it
shear
means
force
shear
is
force is
0.
0.
So
So
this you
this you
can
can
say
say
that
that
it is a
it is a
case
case
of
of
pure
pure
bending.
bending.
Sometimes it
Sometimes it
happens,
happens,
it will
it will
also
also
happen
happen
that
that
only
only
shear
shear
force will
force
be
will be
there
there
and there
and
will
there
be
will be
only shear
only shear
force,
force,
no
no
bending
bending
moment.
moment.
Then it will
Then
be
it
a
will be a
case of
case of
pure
pure
shear.
shear.
Okay.
Okay.
Now
Now
let's move
let's
to
move to
indeterminacy.
indeterminacy.
You
You
have to
have to
find
find
the
the Indeterminacy of this beam with having an internal hinge at its midspan. So, how we define this indeterminacy? So, indeterminacy is generally defined as two things. First is static indeterminacy, another is kinematic indeterminacy. In static indeterminacy, you will find the external forces and the internal forces acting in the member. Who is coming? Okay. You will find the external and internal forces in the member. Whereas in kinematic indeterminacy, you will try to determine the rotations and displacements on the member. So, what is a determinate structure? As I have already in the starting of the class told you that you have to analyze determinate structures, indeterminate structures by different methods. So, what is a determinate structure? So, a determinate structure is that one in which the number of unknowns, that is, the reactions, is equal to equilibrium equations. So, you have three equilibrium equations. One is horizontal force in horizontal force in x direction is zero, vertical force is zero, third is summation of moment is zero. So suppose you have a beam, simply supported beam. You have to, this is a beam, you are having reactions here, RH, RH, RY, R, R. So you are having three reactions. In hinge you have two reactions and one reaction you are having the roller support. So here what will happen, that total you are having three reactions, three equilibrium equations. Your static indeterminacy will be zero. Now when you have this indeterminacy, number of unknowns greater than the number of unknowns greater than the equilibrium equations, then it is indeterminate structure.
Sir, what is unknown?
Unknown means reactions. Suppose you have this beam Rx, Ry, Rr. These are your unknowns. You have to calculate based upon the equation that are available to you. So in this case, you have three unknowns, three equilibrium equations. So your ds is coming out to be zero. But what will happen if you have a fixed beam? You have a fixed beam, you will be having, here reaction will also be there, both horizontal as well as vertical, and moment is also there. So let's say this is A, this is B. So this will be RVA, RVB,
RHB,
RHB,
RHA,
RHA,
MA,
MA,
MB.
MB.
So
So
here what are the
here, what
number
are
of
the number
unknowns?
of unknowns?
Here
Here
unknowns are
unknowns are
6,
6,
and you have
and you have
equilibrium
equilibrium
equations
equations
3.
3.
So
So
what will be
what
your
will be your
static
static
indeterminacy?
indeterminacy?
DS.
DS.
It will
It
come
will
out to
come
be
out to
6
be 6
minus 3
minus
equal to
3 equal
3.
to 3.
This is
This
how
is
you will
how you will
calculate the
calculate
static
the static
indeterminacy.
indeterminacy.
So
So
this
this
will
will
also
also
help us
help us
this
this
in
in
static
static
indeterminacy,
indeterminacy,
helps you
helps you
to
to
define
define
stability of the
stability of the
structure.
structure.
So
So
if
if
ds
DS
is
is
coming out to
coming
be
out to be
negative,
negative,
then it will be
then it will be
unstable.
unstable.
If
If
ds is coming out
DS
to
is
be
coming
0,
out to be 0,
then it will
then
be
it will be
just
just
stable
stable
or
or
unstable.
unstable.
Stable
Stable
or
or
unstable,
unstable,
or rigid,
or rigid,
not
not
unstable.
unstable.
When it is
When it is
positive,
positive,
it will be
it will be
overstable
overstable
or
or
over rigid.
over rigid.
This is
This
how
is
you
how you
determine
determine
the
the
stability of the
stability of the
structure
structure
using
using
static
static
indeterminacy.
indeterminacy.
Sometimes you
Sometimes
also
you
have to
also have to
find
find
the
the
static
static
indeterminacy for the
indeterminacy for the
beams
beams
or
or
frames
frames
that you will
that will
study,
study
that
that
ds.
Excuse me,
DS.
sir.
Yeah.
Yeah.
Sir, I did not understand that how to determine number of unknowns and equilibrium equations.
Okay.
Okay.
So
So
we
we
see
see
you have
you
a
have a
fixed
fixed
Finn's
Fitz
reaction
reaction
support.
support.
So in
So in
Finn's
Fitz
reaction
reaction
support,
support,
how many
how many
unknowns are
unknowns
there?
are there?
You have
You
three
have three
unknowns:
unknowns: RH,
RB, and
RB, and
MA.
MA.
Is it
Is
fine?
it fine?
Yes, sir.
These three
These three
unknowns, I
unknowns,
will
I will
mark it
mark
as
it as
this
this
RBA,
RBA,
MA,
MA,
RHA.
RHA.
These are the
These are the
three
three
unknowns
unknowns
which are
which are
there
there
in
in
support A.
support A.
In
In
support B, you
support B,
have
you have
MB,
MB,
MHB, and
MHB,
VB.
and VB.
So
So
based upon the
based upon the
kind of
kind of
support that you
support
are
that you are
using,
using,
your
your
unknowns will
unknowns
be
will be
changed.
changed.
Suppose in
Suppose in
previous
previous
section it
section
has
it has
RH and
RH and
RY and
RY and
RR,
RR,
where Finn
where
support
Fin
has
support
two
has two
unknowns,
unknowns,
where
where
roller support
roller
has
support
one
has one
unknown.
unknown.
In Finn
In Fit
support you
support,
have
you
three
have three
unknowns.
unknowns.
So
So
in this
in this
case
case,
the
the
unknowns comes
unknowns
out to
comes
be
out to be
1,
1,
2,
2,
3,
3,
4,
4,
5,
5,
6.
6.
Okay,
Okay,
that is
that
fine.
is fine.
Then you
Then
have
you
three
have three
equilibrium
equilibrium
equations.
equations.
You have
You have
summation of
summation of
moment equal
moment
to
equal to
0,
0,
summation of
summation of
forces equal
forces
to
equal to
0,
0,
summation of
summation of
horizontal force
horizontal
equal to
force
0,
equal to 0,
summation of vertical
summation
force
of
equal to
vertical
0.
force equal to 0.
So if you
So
have
if you
three
have three
equations,
equations,
six
six
unknowns,
unknowns,
so it
so
means
it
you
means you
can't
can't
solve
solve
all of
all
them.
of them.
So
So
that is your
that is
static
your static
indeterminacy.
indeterminacy.
So it
So
means you
it
have
means you
six
have six
unknowns,
unknowns.
you have
You
only
have
three
only three
equations to
equations to
solve.
solve.
So
So
its
its
static
static
indeterminacy comes out
indeterminacy
to be
comes out to
number
be
of
number of
unknowns
unknowns
6
6
minus 3.
minus 3.
So your
So
static
your static
indeterminacy comes out to be 3.
indeterminacy comes out to be 3.
Now is it fine?
Now is it fine?
Yes, sir.
Okay.
Okay.
So static
So
indeterminacy
static
can be
indeterminacy can be
external
external
static
static
indeterminacy that we are
indeterminacy that
currently
we are
finding
currently
it
finding
out,
out,
and it can
and it
also
can
be
also be
internal static
internal static
indeterminacy.
indeterminacy.
For
For
beams
beams,
it is
it is
0.
0.
DSI is 0.
DSI is 0.
That will,
That will,
I am
I
just
am
giving you
just giving you
overview idea.
overview idea.
Later on
Later on,
when the
when the
question will
question
come,
will come,
we will
we will
see that
see
how
that
you will
how you
find
will
the
find the
internal
internal
static
static
indeterminacy.
indeterminacy.
Here,
Here,
internal static
internal static
indeterminacy
indeterminacy
is
is
n
n
into number
into
of
number of
closed loops.
closed loops.
You see
You
these
see these
closed
closed
loops
loops
in a
in
frame
a
kind of
frame
a
kind of a
structure.
structure.
So
So
suppose
suppose
I will
I will
make a
make a
frame.
frame.
This is a
This is a
frame.
frame.
Okay.
Okay.
It is
It is
having a
having a
fixed.
fixed.
I will
I
not
will not
use this.
use
I will
this. I
use
will
fixed.
use fixed
Then
fixed. Then
it
it will
will
be
be
easy
easy.
for you.
Okay.
Okay.
So
So
these are the
these are the
fixed loop.
fixed loop.
Number of
Number of
loops means
loops means
these
these
loops.
loops.
Loop
Loop
1
one
and loop
and
2.
loop two.
Loop 1,
Loop one,
loop 2.
loop two.
So these are
So
the
these are
two
the two
loops.
loops.
So
So
if you
if you
cut
cut
one,
one,
two,
two,
three,
three,
three
three
loops
loops
are there,
are there,
and
and
here
here
3 into
3
3
into
comes
3
out to
comes
be
out to be
9.
9.
Why 3
Why
is
3
there?
is there?
Because we
Because
have
we have
sigma
sigma
fx
fx
or
or
horizontal
horizontal
force.
force.
I will
I
write
will write by this
sigma
sigma
h
h
equal to
equal
0,
to 0,
sigma
sigma
v equal
v
to
equal to
0,
0,
sigma m
sigma
equal
m
to
equal
0.
to 0.
Multiply by
Multiply by
3
3
unknowns,
unknowns,
3 number
3
of
number
closed
of closed
loops.
loops.
This is how
This is how
you will
you will
find the
find
static
the static
indeterminacy.
indeterminacy.
And
And
external
external
indeterminacy, how
indeterminacy,
you
how
will
you will
find?
find?
You will
You will
find
find
DSE
DSE
equal to
equal to
R
R
minus E
minus E
that you are
that you are
already
already
using,
using.
means
Means
number of
number of
unknowns
unknowns
minus
minus
equilibrium
equilibrium
equation.
equation.
Also
Also,
sometimes
sometimes
happens
happens
that
that
an
an
internal
internal
hinge come
hinge
in
come in
between.
between.
So we
So
will
we will
write as
write it
A.
as A.
Mostly
Mostly
used
used
for
for
internal
internal
hinge.
hinge.
Okay.
Okay.
So
So
suppose
suppose
if you
if
have
you
this
have this
member
member
and here
and
and
here
one
and one
internal
internal
hinge is
hinge
also
is
there.
also there.
So you
So
will
you will
subtract
subtract
1 from
1
it
from it
and it will
and it
come
will
out to
comes
be
out to
8.
be 8.
Okay.
Okay.
This is
This is
how you
how
will
you will
solve the
solve the
problem of
problem
static
of static
indeterminacy.
indeterminacy.
Now,
Now,
what
what
what will
what will
happen
happen
if you
if you
have
have
both the
both
roller
the
roller?
roller?
Here
Here
reaction will be
reaction will
2,
be 2,
equilibrium equations
equilibrium
are
equations are
3.
3.
So your
So your
ds is
ds is
2
2
minus
minus
3
3
equal to
equal to
minus 1,
minus 1,
which is
which is
unstable.
unstable.
Another
Another
thing,
thing,
so
so
these are your
these are
two
your two
unrolling
unrolling
reactions.
reactions.
If
If
that
that
this thing we have
this thing we
already
have
covered.
already covered.
Here
Here
ds comes
ds
out to
comes
be
out to be
0.
0.
It is
It is
just
just
stable.
stable.
If you
If
have
you
a
have a
cantilever
cantilever
beam,
beam,
here
here
you
you
have
have
three
3
reactions.
reactions.
R is
R is
3,
3,
E is
E is
3.
3.
So
So
ds
ds
comes out
comes
to
out
be
to be
3
3
minus
minus
3
3
equal to
equal to
0.
0.
Just
Just
stable.
stable.
In
In
prop
prop
cantilever,
cantilever,
you are
you are
having
having
3
3
reactions
reactions
here,
here,
1
1
reaction
reaction
here.
here.
So
So
your
your
R will
R
be
will be
4,
4,
equilibrium
equilibrium
equations are
equations are
3.
3.
So your
So your
ds
ds
comes out
comes
to
out
be
to be
4
4
minus
minus
3
3
equal to
equal
1.
to 1.
So it
So
will
it
be
will be
overstable.
overstable.
So this
So
is
this is
how
how
you will
you will
define the
define the
static
static
indeterminacy.
indeterminacy.
Now
Now
going to
going
this
to this
question,
question,
you
you
have
have
to
to
calculate
calculate
the
the
static
static
indeterminacy of
indeterminacy of
this.
this.
So
So
here you
here you
have
have
reactions.
reactions.
Okay.
Okay.
So here
So
total
here total
reactions comes
reactions
out to
comes
be
out to be
6
6
minus
minus
3
3
equilibrium
equilibrium
equations
equations
minus
minus
1 comes
1
out to
comes
be
out to be
due to this
due to this
hinge.
hinge.
So your
So your
total
total
static
static
indeterminacy
indeterminacy
comes
comes
out to
out
be
to be
2.
2.
Okay.
Okay.
Another way
Another way,
you can
you
also
can
try
also try
divide them
divide
into
them
two
into
beams.
two beams.
This is one
This is
beam,
one beam,
this is
this
another
is
beam.
another beam.
So
So
here
here
you are
you are
having
having
three
three
unknowns.
unknowns.
Hinge will
Hinge will
also give
also
you
give
two
you two
reactions,
reactions,
RX R
RX
by,
R by,
and here
and here
also you
also
will
you will
have three
have three
reactions.
reactions.
So now
So now
here
here
3,
3,
here
here
2,
2,
here
here
2,
2,
here
here
3,
3.
and
And
so
so
these
these
all
all
your
your
will be
will be
unknowns,
unknowns.
and
And
each
each
beam
beam
will
will
have
have
and
and
each
each
beam
beam
will be
will be
having
having
three
three
equilibrium
equilibrium
equations,
equations,
three
three
equilibrium
equilibrium
equations.
equations.
Therefore
Therefore,
ds
ds
will comes
will
out
comes
to
out
be
to be
3
3
plus
plus
2
2
plus
plus
2
2
plus
plus
3.
3.
So these all
These
your
are your
unknowns.
unknowns.
Minus,
Minus,
since you
since
have
you
two
have two
beams,
beams,
so it
so
will
it
be
will be
2
2
into
into
3.
3.
So it
So
comes
it
out to
comes
be
out to be
3 plus
3
2
plus 2
5 plus
5
2
plus 2
7 3
7 3
10.
10.
We will
We
not
will not
add
add
this
this
2
2
because
because
it
it
already
already
came
came
here.
here.
So it
So
will
it will
be
be
3
3
plus
plus
2 plus
2 plus
3
3
minus,
minus,
you
you
have
have
2
2
beams,
beams,
so
so
3 into
3 into
2.
2.
So it will
So it
be
will be
8
8
minus
minus
6,
6,
you will
you will
have 2.
have 2.
This is
This
how
is
you
how
will
you will
solve this
solve this
problem.
problem.
So this
So
is
this is
what
what
I have
I have
covered
covered
about
about
static
static
indeterminacy.
indeterminacy.
Static
Static
indeterminacy,
indeterminacy, you
you
need
need
to
to distinguish
distinguish
between
between
determinate structures
determinate
and
structures and
indeterminate
indeterminate
structure, where the
structure, where
number
the
of
number of
unknowns when
unknowns,
it is
when it is
equal to
equal to
equilibrium
equilibrium
equation,
equations,
the
the
structure is
structure is
said to be
said to be
determinate.
determinate.
But
But
when where
when
the
where the
number of
number of
unknowns are
unknowns are
greater than
greater
the
than the
equilibrium
equilibrium
equation,
equations,
it is
it
said
is
to
said
be
to be
indeterminate
indeterminate
structures.
structures.
So
So
how you
how you
calculate
calculate
structure
structured
indeterminacy?
indeterminacy?
It will
It
be
will be
using this
using this
formula.
formula.
This is the
This is the
generalized
generalized
formula
formula
you will
you will
use to
use to
find the
find the
static
static
indeterminacy.
indeterminacy.
It is
It is
R
R
minus E
minus E
minus
minus
A,
A,
where
where
R is
R
the
is the
number of
number of
unknowns,
unknowns,
E is
E
the
is the
equilibrium
equilibrium
equation,
equations,
and
and
A you
A
will
you will
define it
define it
as the
as the
additional
additional
restrictions
restrictions
or
or
constraints that
constraints
are
that are
provided in
provided in
between a
between a
member.
member.
It could
It
be
could be
internal
internal
hinge
hinge
or
or
something
something
that is
that is
internal
internal
inside a
inside a
member,
member,
which is
which is
providing the
providing the
restraint to the
restraint to the
structure.
structure.
Okay,
Okay,
fine.
fine.
So
So
these are the
these are
some
the some
example that I
example
have
that I
told
have told
how the
how the
stability is
stability is
defined:
defined:
unstable,
unstable,
just
just
stable, and
stable, and
overstable.
overstable.
Now
Now
again,
again,
we will
we will
calculate
calculate
the
the
reaction
reaction
force
force
at the
at the
fifth
fifth
support
support
of the
of the
beam.
beam.
So
So
let's try
let's
it
try
out.
it out.
Indeterminacy is
Indeterminacy is
covered.
covered.
Now
Now
again,
again,
you have
you
to
have to
focus
focus
on
on
this.
this,
How you
how
will
you will
calculate
calculate
the
the
reaction and the
reactions and the
bending
bending
moments.
moments.
So
So
see, this
see,
is a
this is a
beam.
beam.
It is
It is
having a
having a
25
25
kilonewton
kilonewton
meter
meter
load.
load.
I will
I will
convert this
convert this
load
load
into a
into a
point load.
point load.
So if you
So if
have
you
to
have to
convert this
convert
load,
this load,
see
see
this.
this.
So
So
we are
we are
having
having
three
three
lengths:
lengths:
A,
A,
B,
B,
C.
C.
The
The
whole
whole
length
length
is
is
6
6
meter.
meter.
This is
This
2
is 2
meter,
meter,
and this is
and
3
this is 2
meter.
meter.
Here the
Here the
load is
load is
applied.
applied.
I have
I have
converted the
converted the
UDL into a
UDL into a
point load.
point load.
So
So
it will be
it will be
applied at
applied
the
at the
middle of the
middle of the
section.
section.
So it
So
will be
it
at
will
a
be at a
distance
distance
of
of
6 by
6 by
2.
2.
It will
It
be
will
3
be 3
meter.
meter.
So what will be
What
the
will be the
value of
value
load?
of load?
It will
It
be
will be
25
25
into
into
6.
6.
It will
It will
comes out
comes
to
out
be
to be
150
150
kilonewton.
kilonewton.
And here
And
what is
here
the
what is
value
the
of
value of
load?
load?
It is
It is
10
10
kilonewton.
kilonewton.
This is
This is
also
also
one
one
internal
internal
hinge.
hinge.
B.
B.
This is
This is
internal
internal
hinge.
hinge.
Okay.
Okay,
Solve this
solve this
problem.
problem. So you will solve this problem using first use force equilibrium. Now using force equilibrium, summation of vertical forces should be equal to 0. This implies I will add the reaction forces also. This will be RA. Here also the reaction will be there, but because it is a roller support, RC. This is internal hinge. So RA plus RC is equal to 10 plus 25 plus 6, 150 plus 10. It is 160 kilonewton. Okay. Then we will take this span as separate. Yeah, this span. Because there is a property of internal hinge. I will write it out. In internal hinge, the moment about that point is 0. Okay. This thing only will help us to solve this problem, because in fixed support you can't add moment at support A is equal to 0. So you will take moment at B is equal to 0. If we take moment at B is equal to 0 and consider only the right half span, means only the this span if we consider, we will have, considering right side. Okay. So it will be 4 into RC minus 10 into 2. So the value of RC comes out to be 20 divided by 4. It will be 5 kilonewton. If you want, you can check also. Okay. Now what will be the value of RA? Substituting in the above equation, we will have RA equal to 160 minus 5. RA will be 155 kilonewton. Yeah. So this is your reaction at RA. So at reaction at RA comes out to be 155 kilonewton. Suppose if you also have to determine the moment, how you will determine it. So for that, consider moment about B equal to 0. RA and consider left span only. You will be having RA multiplied by 6, which is the distance, minus RA, because we are taking here the moment. So this will be MA. Anti-clockwise will be negative, clockwise will be positive. Then we will take load also. This is our load. It will act at a distance of 6 by 2. Okay, it will be equal to 0. We have a value of RA also, 155 into 6 minus MA, minus this comes out to be 25 into 18. It comes out around 450 equal to 0. So your moment at A will comes out to be 450 minus 155 into 6, around 930. So your moment will come at 480 kilonewton meter. Okay.
So
So
this is
this
how
is
you
how
will
you will
solve this
solve this
problem.
problem.
Again,
Again,
you have
you
to
have to
find that
find that
the
the
reaction at
reaction at
support
support
A,
A.
that will be easy
That
for
will be
you.
easy for
Now
you.
you have
Now
done
you have
several
done several
problem
problem
for
for
this.
this.
You just
Just
use
use
equally
equally
force
force
equilibrium.
equilibrium.
Using
Using
force
force
equilibrium,
equilibrium,
you will
you will
have
have
here
here
RA
RA
plus
plus
RB.
RB.
Okay,
Okay.
so
So
RA
RA
plus
plus
RB
RB
will be
will be
equal
equal
to
to
8
8
plus
plus
4
4
equal to
equal to
12
12
kilonewton.
kilonewton.
Now
Now
use
use
moment at
moment at
A
A
equal to
equal to
0.
0.
That will be
That will be
equal
equal
to
to
8
8
into
into
3
3
minus
minus
RB
RB
into
into
6
6
plus
plus
4
4
into
into
9
9
equal to
equal to
0.
0.
That will
That
be
will be
24
24
minus
minus
6
6
RB
RB
plus
plus
36
36
equal to
equal to
0.
0.
These are
These are
all
all
you are
you are
taking
taking
at
at
8
8
into the
into the
distance
distance
that is
that is
there.
there.
Then you
Then
have
you have
RB
RB
into the
into the
distance
distance
6
6
meter, it
meter
is
it is
there.
there.
And then
And
you
then
have
you have
4
4
meter,
meter
4
4
kilometer
kilometer
multiplied by
multiplied
this
by this
distance,
distance
total
total
9.
9.
Solving all
Solving
of
all
them,
of them,
what you will
what you
get?
will get?
36 and
36 and
24,
24.
it is
It is
60.
60.
So
So
60
60
minus
minus
6
6
RB is
RB is
equal to
equal to
0.
0.
This
This
implies
implies
RB is
RB is
equal to
equal to
60
60
upon
upon
6
6
equal to
equal to
10
10
kilometer.
kilonewton.
Okay,
Okay.
then
Then
you
you
have
have
RA
RA
plus
plus
RB
RB
equal to
equal to
12
12
kilonewton.
kilonewton.
This will
This will
implies
implies
RA
RA
equal to
equal to
12
12
minus
minus
10
10
equal to
equal to
2
2
kilometer.
kilonewton.
Okay,
Okay.
this is how you
This is how
solve
you
this
solve this
problem.
problem.
You
You
have
have
RB
RB
equal to
equal to
10
10
kilonewton.
kilonewton.
You have
You have
RA
RA
equal to
equal
2
to 2
kilonewton.
kilonewton.
You
You
require
require
only
only
RA,
RA,
so the
so the
value of
value
RA
of RA
is
is
2
2
kilonewton.
kilonewton.
Another
Another
question.
question.
Here you
Here
are
you are
having
having
a
a
UVL,
UVL,
not a
not a
UDL.
UDL.
You
You
have to
have to
find
find
its
its
bending
bending
moment.
moment.
How you
How
will
you will
calculate that?
calculate that?
Take it,
Take it,
provide
provide
reactions,
reactions,
RA,
RA,
RB.
RB.
Here the
Here the
load
load
is,
is,
if
if
this thing
this
will be
thing will be
applicable till
applicable
I
till
am
I am
calculating only
calculating
the
only the
reaction
reaction
force.
force.
So
So
here I
here
am
I am
calculating
calculating
into
into
point
point
equivalent
equivalent
point load.
point load.
It is
It
1
is
by
1 by
2
2
into
into
10
10
into
into
10.
10.
It is
It is
50
50
kilonewton.
kilonewton.
Okay.
Okay.
Therefore,
Therefore,
summation of
summation of
vertical
vertical
force is
force is
equal to
equal to
0.
0.
This
This
implies
implies
RA
RA
plus
plus
RB
RB
equal to
equal to
50
50
kilonewton.
kilonewton.
Next,
Next,
you will
you will
take
take
moment
moment
about A
about A
equal to
equal to
0.
0.
So
So
moment of
moment of
A
A
about
about
A
A
equal to
equal to
0.
0.
You will
You will
take it
take
as
it as
RB
RB
into what is
into
the
what is the
distance?
distance?
10 meter
10 meter
minus
minus
this
this
load
load
1 by
1 by
2
2
into
into
10
10
is
is
the
the
load that is
load that is
acting
acting
multiplied the
multiply the
distance
distance
10.
10.
And what
And
will be
what
the
will be
distance?
distance?
Distance will
Distance
be
will be
10 by
10
3.
by 3.
Okay.
Okay.
Solve
Solve
this
this
equal to
equal to
0.
0.
Solve this,
Solve this,
you will
you
get
will get
RB
RB
equal to
equal to
16.67
16.67
kilonewton.
kilonewton.
Okay.
Okay.
So what
So
will be
what
the
will be
value
the
of
value of
RA
RA
here?
here?
Now
Now
RA will
RA
be
will
equal
be
to
equal to
50
50
minus
minus
16.67.
16.67.
RA will
RA
be
will be
equal to
equal to
33.33
33.33
kilonewton.
kilonewton.
Now you
Now
have
you
to
have to
find
find
the
the
moment
moment
at the
at the
midspan.
midspan.
So
So
let's
let's
copy this
copy this
image.
image. Yeah.
You
So you
have to
have to
find the
find the
moment
moment
at the
at the
midspan.
midspan.
Okay.
Okay.
At a
At a
distance
distance
of
of
5
5
meter.
meter.
I am
I am
using
using
this
this
span
span
because
because
this will
this will
provide me a
provide me a
triangle.
triangle.
If I
If I
use
use
this
this
span,
span,
it will
it will
provide me
provide me
trapezium,
trapezium.
then it will
Then
be
it will be
difficult for
difficult
me
for
to
me to
resolve the
resolve the
loads.
loads.
Because
Because
for
for
trapezium you
trapezium, you
have to
have to
further
further
divide it
divide it
into
into
this
this
part.
part.
This will
This
be
will be
your
your
UDL
UDL
part,
part,
and then
and
this
then
will
this
be
will be
your
your
UVL part.
UVL part.
You have
You
to
have
take
to
both
take
the
both the
loads. So
loads.
for
So for
easiness, I am
easiness, I am
taking the
taking the
right hand
right
side
hand
of the
side of the
section.
section.
So
So
moment at
moment at
midspan,
midspan,
the
the
matrix
matrix
will be
will
equal
be
to
equal to
RB
RB
into
into
5
5
minus
minus
this load
this load
1 by
1 by
2
2
into
into
5,
5.
and what will
And
be
what
this
will be
value?
this value?
So
So
use the
use the
triangular
triangular
property.
property.
10
10
upon
upon
10
10
is
is
equal to
equal to
h
h
upon
upon
5.
5.
This
This
implies
implies
h will be
h will be
equal to
equal to
10
10
into
into
5 by
5 by
10.
10.
It will be
It will
equal
be
to
equal to
5
5
kilonewton per
kilonewton per
meter.
meter.
Okay.
Okay.
So this
So
will be
this will be
5.
5.
Multiply
Multiply
by
by
distance of
distance of
5 by
5 by
3.
3.
So
So
you will
you
get
will
the
get the
value
value
16.67
16.67
into
into
5
5
minus
minus
5 5
5 5
25
25
into 5
into 5
125
125
divided by
divided by
6.
6.
So your
So your
MHX
MHX
will
will
be
be
62.52
62.52
kilonewton
kilonewton
meter.
meter.
This is the
This is the
value of the
value of the
moment
moment
at the
at the
midspan.
midspan.
Now
Now
another
another
question is
question is
there.
there.
What
What
will be
will
the
be the
variation of the
variation of the
bending
bending
moment and
moment and
shear
shear
force
force
diagram for
diagram
a
for a
uniformly
uniformly
distributed
distributed
loading?
loading?
So
So
see,
see,
this is
this
a
is a
simply
simply
supported
supported
beam
beam
subjected to
subjected to
uniformly
uniformly
distributed
distributed
load.
load.
At
At
center,
center
at
at
over the
over
whole
the
length
whole
of the
length of the
beam,
beam,
W
W
per
per
meter.
meter.
So
So
you will
you will
see
see
that
that
if you
if you
calculate
calculate
here the
here the
reaction
reaction
RA,
RA,
suppose I am
suppose I
taking
am
the
taking the
section
section
X.
X.
So
So
what will be
what
the
will be the
value of
value
shear
of shear
force?
force?
Suppose I am
Suppose I am
defining the
defining the
value of
value
shear
of
force
shear
as
force as
V.
V.
At
At
Xx it
Xx
will
it
be
will be
RA
RA
minus
minus
W
W
into
into
X.
X.
Okay.
Okay.
So
So
it
it
means
means
that
that
the
the
whole
whole
equation
equation
of
of
V
V
is
is
is the
is the
function of
function of
X.
X.
This,
This,
so it
so
will
it
be a
will be a
linear
linear
equation.
equation,
Linear
linear
equation.
equation.
Whereas if
Whereas
I
if I
calculate the
calculate the
bending
bending
moment
moment
diagram,
diagram,
suppose I
suppose
am
I am
defining by
defining by
M,
M,
it will
it
be
will be
RA
RA
into
into
X
X
minus
minus
W
W
into
into
X
X
into
into
X by
X
2.
by 2.
Okay.
Okay.
It will
It
be
will be
RA
RA
into
into
X
X
minus
minus
WX square
WX square
upon 2.
upon 2.
So what
So
is
what is
this?
this?
This is a
This is a
quadratic
quadratic
equation.
equation.
This is
This
how
is how
we need
we
to
need to
remember
remember
this.
this.
So now
So now
find out
find out find
how
how
this
this
variation is
variation is
described. It
described.
will show
Will
you.
show this.
So for
So
the
for
shear
the
force
shear force
diagram,
diagram,
it will
it will
move,
move.
RA will
RA
go
will
up,
go up.
then
Then
it will
it will
go
go
down,
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 down. and I will make again it. Okay, and then it will go up. Yeah. Whereas bending moment diagram is like this. It is a quadratic function, so it will increase, 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 and then it will decrease, decrease, decrease. So yeah, this is our bending moment diagram. Okay, so it will have a value here. It will be 0. Here it will be having the maximum value RA, RB, positive, negative. This value will be WL by 2, WL by 2. Here it is 0, 0, positive. The maximum value you will calculate, it comes out to be WL square by 8. If you want, you try to put the value of here equal to 0. Sorry, H equal to L by 2, and then you will get the value WL square upon 8. So this is how you will solve any problem. Similarly, you can solve this problem for uniformly varying load. So this is what we have covered in this whole session, where you need to remember that how you need to calculate the bending moment diagram, shear force diagram, static indeterminacy, and this covers our week first. In week first, we have to do equilibrium things, stability, determinacy, shear force, and bending moment diagram. And that we all have covered in this class. And all the lectures will also be provided to you by sir. And if you have any question, you can ask me just now. Anyone having any doubt?
No, sir.
I have missed a little bit class, so should I having this note, sir?
Sorry, can you repeat?
I have missed the class in the morning,
Okay.
in the early.
Okay.
So should I have?
Yeah,
Should I
you will
have?
get the link as well as a link of this video, as well as all the questions that are solved will be provided to you in the Google Classroom folder. That you don't have to worry. All the slides as well as the video will be provided to you.
Okay, okay, sir. Thank you so much, sir.
Anyone else? If no doubt, just please see that how we are solving these problems, and in this way only you have to solve the assignment 1 that is provided to you. And if you have any doubt also, you can use the NPTEL discussion forum, where if you have doubts, we will definitely try to provide you the solution regarding the same. Use that platform for asking the doubts. Okay?
Thank you so much. Okay, thank you so much.
Okay. So we will end this class now. Others, if they want, can leave. Okay. Thank you, everyone.